Imagine your entire business operation freezing because a single cable snapped. That scenario is exactly why we need to talk about network topology. It is the structural blueprint of your entire IT ecosystem. This blueprint exists in two layers. First is the physical topology, the literal, tangible layout of cables, routers, and switches installed in your building. Second is the logical topology. This is the invisible path that your data packets actually take to navigate through all that physical hardware. You have to map both. If you only look at where the wires run without understanding the logical data flow, troubleshooting a downed network becomes a blind guessing game. If you start running cables without a strategic plan for both of these layers, you build accidental bottlenecks that put your daily operations at risk. Take a look at this decision tree for a new network build. You have 6 primary physical topologies to choose from, and your path depends entirely on 2 competing variables, your budget and your downtime tolerance. Simple architectures are incredibly tempting. They save you money upfront on hardware and require fewer installation hours. But those upfront savings have a consequence. You are actively consolidating your operational risk into single points of failure. On the other end of the spectrum, if you require absolute zero downtime reliability, you have to build highly redundant hardware setups. That route guarantees your connection stays live, but it requires exponentially higher cabling costs and hundreds of hours of configuration labor. Your job isn't to find an objectively perfect network layout. It is to find the specific layout that aligns what you can afford to spend with what you can afford to lose. Let's start with the legacy options. Historically, if you had a tight budget, you built a bus topology. In this diagram, you see a classic bus layout. A single continuous backbone cable connects every device in a straight line. It keeps hardware costs incredibly low, but comes with a fatal trade-off. If that backbone wire takes damage, the entire network drops offline instantly. Then there is the ring topology, which was designed as a specialized solution to prevent data collisions. Look how this maps out. Devices connect in a closed circle. Data packets travel in a single direction, eliminating traffic jams. But the vulnerability is obvious. If one device goes offline or a cable is cut, the circle breaks and data stops dead. Both bus and ring setups sacrifice systemic reliability for the sake of strict simplicity. For modern critical operations, they are simply too fragile. That brings us to the baseline standard for modern homes and standard office spaces today, the star topology. Here, you can see the architecture clearly. Every peripheral device connects directly to one central hub. The main advantage is isolation. If one computer or cable fails, it doesn't affect the office. Data keeps flowing between the central hub and all active nodes. This hub-and-spoke layout makes it exceptionally easy to track down bugs or plug in new devices as your team grows. But there is still a consolidated risk. That central switch is doing all the heavy lifting. If that central piece of hardware loses power or suffers a critical error, every single connected node is displaced at exactly the same time. Star topology is the ultimate middle ground.
You get high operational convenience, but you have to establish absolute protection for that central hardware. If your data absolutely cannot go offline under any circumstances, you have to look at the enterprise-grade solution, mesh topology. This diagram illustrates true redundancy. In a mesh layout, every single device is hardwired directly to every other device in the network. Even if multiple cables are severed simultaneously, the system doesn't blink. The data packets simply reroute along alternative paths to reach their destination. The catch is the financial requirement. Every time you add a new device, the amount of physical cabling required scales exponentially. And the hardware is only half the battle. You need massive software configuration to correctly manage traffic routing through this dense web. Mesh topology guarantees your uptime, but it demands capital investments that are entirely unjustifiable for standard business needs. Large corporate campuses eventually outgrow a single design philosophy. That's when they move to a hybrid topology. You can see in this layout how a hybrid system combines multiple standards. Here, a central bus backbone bridges 3 separate star topology hubs. This setup lets different departments optimize for their own traffic. The sales team might use one layout, while engineering utilizes another. The operational drawback is maintenance. Managing a network that bridges different, often incompatible setups requires highly skilled, dedicated IT personnel. You also have to factor in the massive upfront capital required for the specialized hardware that integrates these differing architectures. Hybrid networks give you unmatched flexibility, but they force your organization to accept permanent, high-level maintenance overhead. So, how do you make the choice? It comes down to evaluating 3 metrics: your network size, your available budget, and your specific performance needs. Look at this cost to reliability matrix. If you are a small business or a home office with limited IT staff, you fall into profile A, perfectly aligned with the star topology, right in the middle. Its low installation cost and simple scaling process fit perfectly with a restricted budget. Now, if you are an enterprise IT planner handling medical data or financial transactions, you are profile B. You need the mesh and hybrid solutions in the top right quadrant. For those organizations, a sudden outage could result in multi-million-dollar losses. The catastrophic consequence of downtime easily justifies the massive infrastructure spend. Explicitly mapping your architecture to your business profile keeps you from overspending on redundancy you don't need or underprotecting assets you can't afford to lose. Computer networking experts consistently emphasize one core rule: there is no single solution that fits every environment. Please do not fall into the trap of buying enterprise-level redundancy if you only have a simple use case. Conversely, do not try to save pennies on cabling and switches that support a revenue-generating enterprise. Before you purchase a single router or run a single wire, clearly define your hard budget limits and your exact downtime tolerance. The choice of network topology dictates your organization's operational resilience, making it a critical business decision.